So here's question 2 of the 2023 Euclid Contest. If you'd like to try it out, pause the video now. If you'd like to see how to solve it, keep watching. Before we look at part A, there's one definition we need to know. The x-coordinate of the midpoint is going to be the average of the two x-coordinates, and the y-coordinate of the midpoint is going to be the average of the two y-coordinates. Now that we know what a midpoint is, let's look at part A. 5, 3 is the midpoint of 1, p and r, 5. What are the values of p and r? So all we have to do here really is just apply the definition of a midpoint. The x-coordinate of the midpoint is going to be the average of 1 and r, and the y-coordinate of the midpoint is going to be the average of p and 5. So when you have one coordinate equal to another, you can think of that as two equations. One equation for the x-coordinate and one equation for the y-coordinate. So here we have that 5 is equal to 1 plus r over 2, and that 3 is equal to p plus 5 over 2. Both these equations just have one variable, so we can just solve for r and p individually. In both equations, we'll multiply by 2, and then in the left equation we'll subtract 1, and in the right equation we'll subtract 5. And we get that r is equal to 9, and that p is equal to 1. And that's our final answer. Before looking at part B, let's look at some other definitions. Knowing about the slope-intercept line equation will make this much easier. If you already have an equation for your line, you can just rearrange the terms so it's in slope-intercept form, and then you can easily find what the slope is and what the y-intercept is. And vice versa, if instead you know what the slope is and what the y-intercept is, then you can easily figure out what the line equation is. And speaking of the y-intercept, just a reminder that that's where the line crosses the y-axis. And since all points on the y-axis have an x-coordinate of 0, another way to think about the y-intercept is the point on the line where the x-coordinate is equal to 0. And similarly, the x-intercept is where the line crosses the x-axis, or in other words, the point on the line where the y-coordinate is equal to 0. So let's look at part B. A line with slope 3 and another line with slope -1 intersect at 3, 6. What is the distance between the x-intercepts? To solve this, we'll just find the two x-intercepts and then find the distance between them. I'll first rearrange the information we have. I'll group the information about line 1 together and the information about line 2 together. So we know that one line has a slope of 3, that the other line has a slope of -1, and that they both go through the point 3, 6. So let's try to translate the English words into math. So we only have the slope, we don't have the y-intercept. So we can't get the exact line equation yet. But we can still partially fill it in and leave a variable for the information we're missing. So since the slope of the first line is 3, the equation of the first line is going to look something like y is equal to 3x plus something. And since the slope for the second equation is -1, the equation for the second line is going to look like y is equal to -x plus something. So we also know that both lines go through 3, 6. A point being on the line means that if you plug in that point into the line equation, you'll get something true. So let's just plug in x equals 3 and y equals 6 and see what we get. With these two equations, we can solve for b1 and for b2. Now that we have b1 and b2, we now have the full line equation for both lines. So now let's find the x-intercepts. So remember, the x-intercept is the point on the line where the y-coordinate is equal to 0. So let's just plug in y is equal to 0 and solve for x. So the x-intercept for the first line is 1, 0, and the x-intercept for the second line is 9, 0. Since both these points are on the y-axis, the distance between them is just the difference between their x-coordinates. So all we have to do is 9 minus 1, and we get 8 as our final answer. So that was the straightforward way to solve this question, but we ended up doing a bit more work than we needed to. So here's another way to think about it. So we know that line 1 has a slope of 3. That means that every time we take a step to the right, we go 3 units up. Or in other words, every time we take a step to the left, we go 3 units down. And line 2 has a slope of -1. That means that every time we take a step to the right, we go 1 unit down. So if we start at the point 3, 6, how many steps do we have to take before we reach the x-axis? For line 1, since every step brings us 3 units down, and we only have to go down 6 units, we only need 2 steps. For line 2, since we only go down 1 unit every step, we'll need to take 6 steps. So if we start at the same point, and one line takes 2 steps to the left, and the other line takes 6 steps to the right, what's the distance between them? Since the steps are in opposite directions, we just add them together. And we also get a final answer of 8. So by solving the question this way, we didn't have to find the y-intercepts of both lines. By solving it this way, we can also see that the x-coordinate of the intersection point doesn't matter. If the intersection point was, let's say, 10, 6 instead of 3, 6, we'd still get the same answer. Before we look at part C, there's one final definition we need to know. So if one line is perpendicular to another, that simply means that the slope of the first line is equal to -1 over the slope of the second line. And that's the only thing we need to know. So let's look at part C. For some value of t, the line with equation y is equal to tx plus t is perpendicular to the line with equation y is equal to 2x plus 7. Determine the point of intersection. So again, I'll just first rearrange the information we have. We have that the equation for the first line is y is equal to tx plus t for some value of t we don't know yet. And we know that the equation of the second line is y is equal to 2x plus 7. And we also know that those lines are perpendicular to each other. So let's apply the definition of perpendicular lines. And we get that the slope of the first line is equal to -1 over the slope of the second line. But here we're lucky. Both our lines are in slope-intercept form, so it's really easy to find the slope of the first line and the slope of the second line. The slope of the first line is just t, and the slope of the second line is just 2. So we get that t is equal to -1 over 2. Now that we know the value of t, we now know the exact equation for the first line. Y is equal to -1/2 x minus 1/2. So we now have 2 fully specified lines, and all we have to do is find the point of intersection. Since both our equations are in line-intercept form, that means that both our y's are isolated. That makes finding the intersection very easy. All we have to do is find a single x value that produces the same y value for both equations. To do that, let's just make the 2 equations equal to each other and solve for x. Let's move all the x's to the left and all the numbers to the right. We get that -5 over 2x is equal to 15 over 2. Let's multiply by -2 and divide by 5, and we get that x is equal to -3. So that's the x-coordinate of our point of intersection. We still have to find the y-coordinate. To do that, let's just plug our x value in either equation. For example, if we plug it inside line 2, we're going to get 2 times -3, that gives us -6, plus 7, that gives us 1. And since this is a point of intersection, these coordinates should also work in line number 1. So a quick way to double check your answer is to just plug in the x and y value in line number 1 as well. So if we do that, we get -1/2 times -3, which gives us 3 halves. -1/2 gives us 2 halves, which is equal to 1 as expected. So our point of intersection is the coordinate -3, 1. And that's our final answer. So that was question number 2. Question 2s tend to be as easy as question 1s. It's just that there's more definitions you need to know. But once you know your definitions, all you need to do is apply them correctly, and the answer will pop out. So that's everything for this question. Thanks for watching.